let's take a look at this problem. So this would be one of the challenging questions. Okay, I'm going to kind of talk through it here a little bit. Okay, when you're working through a problem like this, you're asked to find the total surface area. You do have a regular polygon as your base. This is a regular or equilateral triangle here, all the same side or side length. Okay, so if you want to find the total surface area of this, you can use your formula, right? One base plus 1/2 the perimeter times the slant height. Well, we can first calculate our base is a triangle, 1/2 base times height. And if you look at sort of the top view of this triangle, so this is the top view of your base. Each of these side lengths is 16. And when you draw in your altitude, because that was an equilateral triangle, this was originally a 30, 60, 90. Therefore, splitting this side of 16 in half, this is a leg of 8, which means this other leg, the one opposite 60 degrees, is going to be 8√3. Okay, so you know your base and your height here. 1/2 16 is the base times our height of 8√3. Okay, plus we're going to take 1/2 of our perimeter. Well, we see our perimeter is 3 sides of 16, so there's our p-value. All we have left to find is this slant height. Okay, so here is our slant height. We'll call it L. Okay, in order to find this slant height, you need to use a second calculation. Okay, you know that the height of this the height of this pyramid is 25. So if we drew our perpendicular from the vertex straight down to the middle of that base, we know that that's 25. And then we have this leg from the middle of that base to the edge where the slant height intersects the side. This measure right here is the connection between two of these altitudes. So if I were to draw in two altitudes from this top view, the vertex of that pyramid sits right here at this intersection. And because this is an equilateral triangle, this intersection is all the points of concurrency that we talked about in Chapter 5. So this is also a centroid, meaning it cuts this into a ratio of 2 to 1, right? So you have this 2 to 1 ratio here, which means that this portion, which maps onto this part of our three-dimensional view, is what fraction of the whole altitude for that base. It's a 2 to 1 ratio, so how many total parts are there here? 3, so it's one of those 3. So this portion right here is 1/3 of 8√3. So we know that this is 8√3 over 3. And so that's the information that you're going to use to find slant height. Because if we take that right triangle that's formed there with a leg of 25 and 8√3 over 3 and a hypotenuse of L, you can use Pythagorean Theorem. L squared equals 25 squared plus 8√3 over 3 squared. Extract your square root. And so this is the value that's going to go here. That's our L value. So I can go ahead and plug this all in and get my calculation. So 1/2 of 16 times 8√3 plus 1/2 of 16 times 3 times this whole quantity, which I'll put in a radical, 25 squared plus the quantity 8√3, close the radical on the 3, divide by 3, close the parentheses around that whole fraction and square it, and then close the parentheses around my square root. Okay, I've entered a decimal a couple different places, so my answer should give me a decimal solution. And I get 721.01 if I round it to 2 decimal places as my answer. The units are meters. It's still a 2-dimensional area, and so that would be my calculated value.